Okay, it's 1 o'clock. Welcome everybody. That's another HDF clinic. Um, Lots of things happening on the forum, and I think we have another set of tips and tricks or ruminations maybe this time. Okay, before I continue, for those of you who joined here today, any questions? There weren't any in the Google Doc, but that doesn't mean much. Any questions? Yeah.
Nope, Gerd. This is Robert. Let it roll.
Okay, thank you. Welcome. Okay, announcements. Well, that's more of a repeat. Again, we will have that Volt tutorial on February 25th, and I think it's going to be great. I can tell you internally, we had a dry run on Friday, and yeah, so it's going to be good. I was there for the dry run, and I have sort of an idea what's coming, and yeah, it's going to be great. And I liked it so much. I want to see the real thing now, not just a dry run. And then
Garrett,
it was great. Yes.
Garrett, if I could just ask, who's
Sure.
the target audience for that?
I think that, if I remember correctly, the target audience is, you should know something about HDF5. So people who are completely new to HDF5, I think that's going to be a bit of a stretch. But then, yeah, if you are familiar, you've written applications and so forth, I think that should be fine. I think there is no assumptions about like parallel HDF5 or something like that. I mean, yes, you can use walls also in parallel, but the tutorial itself doesn't really assume that you know something about MPI or parallel computing. So it's for people, for I would say intermediate to advanced users, maybe not exactly beginners, but intermediate to advanced. And
Okay.
okay, thanks. Right, and then just a reminder, I'll remove it next time, but there is a nice blog post out there if you're interested in biological simulations and so forth, and managing data management challenges around that. I think this is a read worth your while. Okay, switching over the forum, there were great discussions there as always. Here's one that I liked, not so much because there was a deep discussion or anything, but it's just a response, kind of succinct response, kind of sums it up, and it's worth highlighting how easy things can be if you use the right tool. In this particular instance, there was a user, maybe I can quickly go there, that basically had a snapshot, a screenshot of HDF view. This is what it looked like to the forum, and was wondering, well, okay, given I have something like that, how can I read this programmatically? And so you see down here the compound, the description, the fields or members as they are called here. The structure pretty much, okay, there's a timestamp, there's an order, there's a serial number, temperature, pressure, and then some kind of array, and then the sort of the element type, the scalar types are listed here, 64-bit unsigned integer, yada, yada, yada. And then the last one, more interestingly, there's actually an array, this array, a 2x2 array of 32-bit integers. So that's what the user posted, and then asked, hey, how can I read this? And Rick, I believe, the maintainer and the main developer of HDFQL, responded with a very concise example that is textbook material, I would say, that just shows how easy it can be with HDFQL in this case, and he chose C++ as the host language. And he basically said, hey, all you need to do is declare the in-memory representation of what you just saw in that screenshot. So capturing that timestamp, that order, that serial number, that temperature, and so forth, and just put C or C++ in this case in-memory types behind this, and then note in particular down here is that 2x2 array of integers. And with that definition, you can define buffer in the case only about reading a single value, but the same would work with a larger array of these, or actually, yeah, I was just confused by 2 by 2. So here we are allocating an array that has 4 of these um, and well, the way, okay, so if you want to create down, you must say, well, this query was actually how I tell HDFQL to write the result of that query that's called read information HDF5. How do I pipe this, so to speak, into something that lives in the address space of my C or C++ program? So in this case, of this values array. And the answer is in HDFQL, there is a mechanism where you can register. It's like you can think of it as a stack or an array where you take variables that are defined in the host language, which in this case is C++, and values is an example of such a variable, where you register such values with HDFQL, and then that gives you like a ticket number. So in this case, it's ticket number 0. You can think of it in array. So if I were to register my next variable, that would be register number 1, then register number 2 for the next variable, and so forth. So that's the mechanism that HDFQL uses to, in a way, make it possible to pass data between the memory of the host language and HDFQL. And so, yeah, then all in HDFQL is really write down a query and then execute it. So in this case, we are doing a select from, that's the name of the HDF5 file, that's the name of the data set, into memory, and then into memory slot 0. That's what we did here. And then the magic happens. So after that, we can iterate, we can loop over this array of 4 records and basically print out the things that we care about, the timestamp, the order, the serial number, and so forth. And then likewise on here for that field that happens to be a 2 by 2 array. And that's it. It looks so simple, and in a way, that's the way it should be. It's very intuitive, very concise. Just think about, okay, write a vanilla C program that does the same thing. Boy, you need this. You have to define compound types. Then you have to create, well, in this case, if you want to read the whole thing, you could get away with H5S all. You don't have to create sophisticated selections and so forth. But just the noise from all the code that you would have to write would be sort of deafening almost. Whereas here it's short and sweet, and it's really, again, textbook stuff for my money. So I thought I highlight that because it's really simple and elegant. And okay, pause here. Any questions about this example or any other questions?
Gerd,
Yeah.
yes, I have a question. If the struct was nested, if that, let's see, if you scroll up there, yeah, if struct data, instead of, let's say, the int array, it had another struct. Can that can be registered with the variable register call as well?
Yes, and off the top of my head, I don't know. So yes, this structure which defines sort of the in-memory type can be arbitrarily nested. I do not know if HDFQL supports arbitrary depth of nesting. So the registration process and so this would be exactly the same. It really matter. However, if HDFQL technically supports, let's say, having here a nested compound, and then you might say, well, can I nest that 2 levels deep or 3 levels deep or however many? I would imagine that there are limits to this, and that's the part that I don't know. Obviously, it works for arrays. Whether it works for nested compounds and how deeply nested compounds, I don't know. But the sort of, call it, the surface structure of the program would be exactly the same.
But the C API, there's no nesting limit with the.
In the C API, there is no limit. Yeah, because, but then you have to write all that code. I mean, that's the difference. You have to write that code manually, whereas here, HDF do well
Yes.
doing some magic. Yeah.
Okay.
Great. Thanks. Yeah. And I'll ask next time I run into Rick, I will ask him if there are any, what the limitations, if any, there might be to nesting types in HDFQL. Okay, then this is something we spoke about last time. There were a few interesting twists here. One, remember the discussion was, can we use external links to read-only data in writable files? Remember, the situation was that someone had a file that they wanted to modify, so they had opened it in read-write mode, and then in that file, there was an external link. However, the object associated with that external link was in a file that was actually read-only. And so the question that we talked about last time was, well, what is the access mode with which the HDF5 library will access when it traverses that external link? What access mode will the HDF5 library apply to that external file? And the answer was that yes, by default, the access mode will be exactly the same as the parent file or the file in which that external link resides. However, there is this API call, h5p set elink acc access flags, that can be used to override that behavior, and in particular, dealing with a read-only file that can be changed so that the library, when it accesses that external file, will open it in read-only mode. And that was all good, but I did not know off the top of my head whether the user, I believe, was using H5Py, whether H5Py actually supported this API call. I was sort of reasonably confident that it would be in the low-level API of H5Py. It turns out Thomas Kloiver replied, and he said he is one of the key maintainers on the H5Py project. And he said that currently H5Py actually does not expose this call, but it would be an easy thing, obviously, to do. However, what would be not so easy is it is unclear, yeah, how do you elevate this to the high-level API in H5Py, maybe through an additional keyword or something like that. That's always a challenge. Is if you, I mean, I think that's one of the strengths of H5Py, that you have the low-level API, the C-level, so to speak, to which you can drop if you want to do something for which there is not yet a nice abstraction, or it's just a new feature where they are still thinking about what would be a Pythonic high-level abstraction for that feature. But then, yeah, in this particular case, it might be just such a corner case that now creating or designing a particularly pretty high-level Pythonic extension or abstraction is maybe not worth the effort. And so, yeah, that was an interesting twist. There was another twist, which was that the user actually did some very diligent testing, and he noticed that there is actually a certain ambiguity in the error message that the HDF5 library generates in the case when it cannot traverse the external link. And sort of the two main reasons for failure to traverse the external link could be A, if the link is dangling, and in fact there is no file to begin with that may contain the object specified in the path name component, so to speak. So in this case, it would be like a file or directory not found error. And the other situation would be like an access permission where the file or directory actually exists and so forth. However, the user the process in the context in which the process runs, the user credentials are just not sufficient um, to access the file. And in that case, in both cases, the HDF5 library just says, I would have to go back to the issue, but in both cases, the HDF5 library basically says, well, I can't access this, but it doesn't really say whether it's due to a permissions problem or whether it's due to a sort of non-existence problem, which is of course, yeah, again, ambiguous, and we could and should be more specific. And so I just created a GitHub issue um, where I asked that to be corrected. I mean, it's relatively easy. It's not rocket science or very difficult development to fix this. But I think, yeah, for developers, this is important information, and yeah, we should be as informative. I wouldn't say verbose, but as informative, as precise as we can be. Okay. Any questions about that or anything else? Okay. Then there was another issue that came in, I think, yesterday or the day before yesterday. That's actually an interesting one, which also gave me an idea for today's tips and tricks. um, okay. The way the user described the issue was they were asking whether there was a parallel bug or bug in a parallel implementation of reading subgroups and so forth. Um, so the idea here was basically the following. What the user apparently wanted to do was, so let's imagine we have a group, for argument's sake, the root group, and then inside of that group we have many subgroups. I think in at some point in his post, the user mentioned that he wanted to do this for over 100,000 groups or subgroups rather. Uh, and he wanted to determine the names of these links. I'm going to say, but then take it back, the names of the subgroups, because they are not really the names of the subgroups, they are the names of the links. So he really wanted to determine the names of these links. And since there were quite a few of them and he was running in parallel, he was thinking, well, wait a minute, maybe I can parallelize that. And let's say I have 100,000 and I have, let's say, 100 ranks. And if I want to determine all these link names, I could just divide this total number of 100,000 subgroups up, and every of my 100 ranks takes 1,000. And then if they each determine the names of the link names of those 1,000 groups, and everything runs in parallel, I actually should come out ahead, and this might give me a nice speed up. Now, that's conceptually, there's absolutely nothing wrong with that. In practice, however, it's a little more complicated than that. Well, first of all, the call that you use to determine the name of a link, there are several different ways to do this, but one, in a way, obvious way to do it would be to say there is in the API in the H5L that deals with links. There is a function called H5L get name by index, where um, so the first question would be, well, where does that index come from? I thought a group is a collection of links and links have names and so forth. So where does that index come from? Well, that index comes from when a group is created and as links are added to this. Yes, the internal representation, there are several representations, but in the earliest version of the file format, there's a B tree associated with such a group. And so it's a B tree, it's not really an array. However, if you if you wish, the natural order would be for these links would be the creation order. So the order in which the links were created, because there's no ambiguity there which link was created before the other links and so forth. So, and so the canonical index would be that. Of course, in a B tree, for example, or any collection, you can also, if you adopt a different sort order, then um, adopting that different sort order at what's at index 15 could be different if you sort link names by name, if you sort links by link name, or if you sort links by creation order, or if you sort them by whatever. So nevertheless, there's this function h5l get name by index. And so the user thought, okay, as part of this parallelization trick to determine the link names, I'm going to just loop over my 1,000. So in our example, let's say we have 100,000 groups, we have 100 ranks. Um, on each rank, I'm just going to loop from 0 to 999, or from 1 to 1,000, and then basically repeatedly call this function h5l get name by index, and just keep incrementing that index. And logically, that is correct. That is something one can do. But there are several issues here. And okay, in practice, it turned out that the user is observing some kind of MPI hang. I'm at this point not sure why. I haven't really. He was so kind to provide an example. I have not had the time to sort of examine that example carefully, but it could be other things. It could be an MPI bug, or definitely it could be an HDF5 library bug. Who knows? But okay, putting that to one side, there are issues with functions like h5l get name by index. In general, actually, for almost there are other functions in HDF5 that where you are retrieving the name of something, and many of them are problematic, at least for that they are typically very expensive operations, in terms of that the HDF5 library does have to do a lot of work internally to retrieve that name. So to give you another example, um, let's say you have an object, a group, a data set, or a linked data type, and you, for some reason, have forgotten or don't have access to a path name to this object. There is a function in HDF5, I believe it's called H5O get name or something like that, or O get path name, maybe, I forgot already. Then where when you call that, there is a call, and it will return you one name, because as we know by now, there can be potentially multiple paths, path names, that is, for a given object, but it will give you one. And that is obviously a very expensive call, because you have to picture yourself in this sort of multi-graph structure that the groups represent, the groups and links. You are basically trying to backtrack a path. You are trying to find a path back to the root group. And that is an expensive operation. So this one is not as expensive. But what makes it expensive, especially in the context of parallel file systems, is if you look at how groups are represented internally in HDF5 through, again, there are different representations, but in the classic form through a B tree, there is a lot going on. And there is a lot of, this is sort of what we would call part of the file infrastructure and of the metadata. This is not, we are not talking here about megabytes. This is hardly even kilobytes. So these are very small items that can be scattered in various places in the HDF5 file. And so from a throughput perspective, this is not good. This is very latency sensitive. And if you do that against, for example, a parallel file system, this is not going to give you very good performance. Now, you could alleviate that a little bit by, instead of sort of doing a for loop and calling this function, you could call, there is a function called h5l iterate, where one of the arguments is a callback function that you provide. And then inside of that callback, you can sort of retrieve one of the arguments to that callback function is the link name. And so you could sort of harvest or accumulate link names as this callback is invoked for every link that's encountered. And but it fundamentally shares the same issue with H5L get name by index, in that the underlying IO that's occurring in the library, maybe the call overhead is a little less here than for H5L get name by index, but it's again lots of small reads, um, lots of small reads, and that is going to be a drag on performance. So I can't recommend that either, especially in the context of a parallel file system. And so the real question is maybe what is really the user's underlying use case, and maybe what he or she wants or needs is really something that we also have in HDF5, a so-called object reference. And so for my tips and tricks, maybe we have 5 minutes left for sure. I wanted to talk a little bit about the difference between links and references, because they can be confusing, but there are sort of practical implications, in the sense that link can be a relatively costly proposition, and if a reference sort of does the trick, you might want to choose a reference rather than a link. But if I do that, I'm going to pause and ask, are there any questions so far? No?
Not so
Okay.
far. Not so far.
Thank you. Good, good. Okay. So the question is, do you need a link or reference? Well, okay, before I ask that question, really, I would quickly go over what is the difference between a link and a reference. In this case, I mean HDF5 object reference, so something that references to an object, and that is a group, a data set, or a data type in HDF5. Okay, so what is a link? Well, a link, broadly speaking, is in HDF5. It is an explicit, unidirectional, named association between a source, and the source is implicitly the group in which that link is actually stored, and a destination. And the destination can be a variety of things. The destination can be the address of another object, can be a path name, it can be a path name in another file, but it's also, there is an API, it can be a so-called user-defined link, so it could be anything. By contrast, HDF object reference is really, is depending on whether you mean the type or a value of that type. But if we stick with the type first, an HDF5 object reference is really a data type. It's an HDF5 data type, like integers or floats or compound types and whatnot. And the values of that object reference data type, they represent references. You might read that as pointers to HDF5 objects in the same or other HDF5 files. That's something recent, that the destinations of HDF5 references can be located in another HDF5 file. The original, the earliest version of HDF5 references, object references that is, did not support that, but I believe in 1.10, in one version of HDF 1.10, we introduced these new references, and so they can now point to objects. There are also references now to attributes. There are references to data set regions and so forth, but I'm not going to talk about those today. So if you just want a cartoonish picture, a link is really this thing where you have a source and a destination, and then there is a name or a label on that association. That's what a link is. And whereas to use sort of C's reference notation, an object reference is really, yeah, you have an object and then you take its address in double quotes, and that address space can be as simple as an object, a byte offset in a file, but it can also be more complicated as a so-called token, or yeah, very general, like a digest, a short checksum or something like that. So what's the similarity between links and references? Well, for one, a link sometimes can be used in a role of a reference. Um, and so a link can be referenced. So if I forget about the fact that the link has a name and that the link is a member of a group, there is sort of a destination to that link. And by traversing that link, that is like referencing something else. So in that sense, sometimes I can use a link like a reference, and I can sort of the act of dereferencing, turning the pointer into a value that it references, would be to traverse the link. Then I'm arriving sort of at the destination, and I'll find out what that object is at the other end. And you can also look at it the same way for references. You could say, well, a reference is kind of an implicit link. It's like a pointer. I'm pointing at something, and yeah, it doesn't have a name like a link that is in a group that is in a group link collection, but it is sort of, call it implicit link if you wish. And uh, as you traverse a link, likewise, a reference has this concept of dereferencing, sort of resolving the address to an object. And in that sense, you could say, yeah, a reference can be traversed in double quotes um, by depending on what the address space is. If the address space is really just a byte offset, and then I just jump to that byte offset, or if it's some kind of more abstract token, but there will be some kind of token resolution mechanism. So those are the similarities. Differences are, okay, links, they are, as we said, they are inseparable from groups. Links in HDF5, links do exist only in the context of groups, and they are not, unlike object references, they are not values of an HDF5 data type. So a link is not something that you can instantiate, that you can construct, that you can describe as a value of an HDF5 data type. Links also have a name. References do not have names. And a very crucial distinction is can be dangling. So you can have a link that just points nowhere. The internet is full of them, hyperlinks that go nowhere, that give you just a whatever 505 or is file not found or something not found. And if links can do that, I mean, to be useful, most of them point to something, but there's no problem with links to be dangling. References, on the other hand, they are values of an HDF5 data type, of type object reference. And we can store them in attributes and in data sets. So you can create a data set, an array, a multidimensional array, if need be, of type object reference. And then you can have each reference in each of these cells of the array, so to speak, point to a different object or to the same object. It doesn't really matter. Unlike links, references have no names. You could say, well, if I have a multidimensional data set of object references, then I could interpret the array index kind of as the name of that link in double quotes. And that's fine. If that works for you, um, we are not going to tell you otherwise, but name is sort of implicit, very different from the explicit name that has a string, a byte string, and a character encoding associated with it in a traditional link. And most importantly, these references, they cannot dangle. So you cannot create an object reference to the no object or to the non-existing object. There is no such thing. So a reference always has to, an object reference that is, always has to point to something. So long story short, there are similarities, but also important differences between links and references. And it's really, it depends on your use case, which is the better choice. I mean, there are certainly performance implications because they are implemented in very different ways. And to come back to the user's original question, when humans talk about 100,000 or more links, maybe uh, what what the user needs is really more of a data set, an array of object references, which then is easy to traverse, and they can do sort of parallel reads on it, like on any other data set. But that, yeah, we'll find out as the discussion continues what the real use case here is. Anyway, and I think I'm afraid that's all we have time for today. Thank you for coming, and we'll be back next week.
All right. Thanks, Gerd.
Thank you. Bye.